Alright, so your favourite combinatorics we're going to use to explain the different number of factors that this could have. Alright, so we know that n equals p to the a, q to the b. So all factors of n, any factors of n, if you think about it, so p and q are both primes, right? So factors will be in the form of, so we'll have a number of p's, like a might be cubed, so we could have p to the 0, p to the 1, p squared, or p cubed. So we could have any of those. So to make that p to the I and q to the j. So again, q is another prime, so we could have, one of it or square of it or none of it, etc. So if you think that I there, that where I is going to be between, we could have 0 of the p's, p to the 0, so 1, all the way up to a, we could have all of them. And for j, we could have the same thing, all the way up to b, or none of them. So any of those integers. So if you think that's including a and including 0, that's a plus 1 possibilities that you could have. And this one, that's b plus 1 because of the 0 possibilities that you could have. And if you think about it, it's like choosing entrees and then mains. Like, how many choices do we have for the first one? A plus 1. How many choices do we have for the second one? B plus 1. So there are that many in total possible choices altogether for the factors. So if we're looking at 80,000, can we do the same thing? So clearly 80,000, if you do a bit of a, a factor tree, you will get the factors, or I think you can put it in your calculator actually, and it gives you the factors. We're going to get two factors just like this one, just like this number n. So it's made up of 2's and 5's, two prime factors. There's 2 to the 7 and 5 to the 4. So if we're thinking of all the different factors of 80,000 that we could have, well, we've got 7 plus 1 actually because of the 0. So 7 plus 1 choices for how many 2's? So we could have 2 to the 0. For example, we could have 2 to the 1 and 5 squared. So that would be 50. 50 is a factor of 80,000. Or we could have 2 to the 0 and 5 to the 1. So that's going to be 5. 5 is a factor. So all these different factors. So we've got 7 plus 1 choices of how many 2's we're including, and 4 plus 1 choices of how many 5's we're including. So you can see that's 8 5's, yes. So 40 different factors we could have there for 80,000.